So Tala, today we are going to study about to study more about the thermal energy stores. We have studied that energy can be converted into different sort of energy stores from one energy store to another energy store, and we have studied about the thermal energy as well. So now today we are going to study that how this energy, this thermal energy, I'm particularly talking about the thermal energy, that how this thermal energy can be transferred from one body to another body. So there are two main ways of transferring the thermal energy from one body to another body, and these ways are called conduction and convention. So we will look deep into these concepts, that how can be energy is transferred through conduction, and how the energy can be transferred through convection. So these are the two main, you can say these are the means by which the thermal energy is transferred. It is not transferred to some other energy stores, rather it is transferred from one body to another body, or you can say from one part of a body to another part of a body. So these are the two major ways. So this in these ways, basically heating is the main element through which the thermal energy is transferred. And when we look into conduction, basically conduction occurs in solids, while convection occurs in liquids and gases. So in order to understand the conduction and convection, you need to have a certain thing in your mind, that is how solids are made up of and how gases and liquids are made up of. You must have known that in solids, the atoms are closely packed with each other. These are so close with each other, closely attached and bounded with each other, that they can only vibrate. They cannot move from one part to another of our body. So in solid this happens, but in case of gases and in case of liquids, the forces between them, or their connection between each other, is a little you can say weak. These are a bit far apart from each other, and they can move, particularly if you talk about the gases. The gas atoms or molecules or gas particles can move from one point to another, but this never happens in case of solids. So if you have this thing clear in your mind, then you can understand the concepts of conduction and convection. Basically what
Yeah.
happens in conduction, basically in conduction is a process in which the heat is transferred, or you can say the thermal energy is transferred from one part of a body to another part of a body through the you can say through vibrating atoms. I have told you that in solids, basically the particles, or you can say the atoms, can only vibrate. They cannot change their position. They cannot move from one part to another. So in
Is
conduction, yeah, sure, you can ask.
is conduction only in solids?
Yes, the conduction happens only in solids, while when we talk about the convection cannot be happened in solids. Rather, it happens only in the case of gases and liquids, right?
Okay.
So
Yeah.
I have told you that in solids, the particles or the atoms vibrates. So how the energy is transferred from one part of solid to another part of solid. Let us say, let me give you an example, that in consider a a bowl of hot soup, and you put a spoon in that, and the spoon is made up of a thermally conducting material. So the one part of the spoon is dipped inside that bowl. So you will feel that when, after a few minutes, after some time, the other end of the spoon will also get heat. It will also become hot. So how this happens? Basically, the thermal energy is being transferred from the bottom of the spoon to the top of the spoon. How? It is transferring through conduction. So are you getting my point?
Yeah.
So in conduction, basically, the heat is transferred through vibrating particles of those of that solid body. In spoon, we have atoms which are at their fixed position and they are vibrating. So what happens? Basically, when we heat that solid, that part of solid, what happens? This heat is transferred. This heat is a form of energy, you know. So this heat is transferred to those to the atoms of that solid at that end, and this heat is converted to the this is, you know, this is thermal energy. So this thermal energy store is transferred to the kinetic energy store of that of those particles. So when we give the kinetic energy of those kinetic energy to those vibrating atoms, they will start oscillating more, they will start vibrating more. Let us say let me draw something for you. Let us say here we have an atom, and first when we hadn't give it the thermal energy, it is vibrating in this space. It had the maximum, it reaches at this point and at these 2 points. So when we give it heat, this heat or thermal energy is transferred to this particle, and it is converted to the kinetic energy of kinetic energy store of that particle. Now when this is transferred to the kinetic energy part of this particle, so it will oscillate, it will start oscillating more. Let us say that it vibrates till here and it reaches at this point. So this particle start vibrating like this. Are you getting my point?
Yeah.
So it starts vibrating more. It means it will, you know, there are millions and billions of atoms inside a small piece of solid. So this will vibrate more. So it means it will start colliding with its neighboring atoms. There will be atoms over here, there might be an atom over here, there might be an atom over here, and everywhere. So this starts colliding with other atoms, and this collision results in their increase in their kinetic energy as well. So this is how from one atom to another the energy is transferred, and from that other atom to another atom, and then it goes on like this, and then you can feel that the temperature of the other end of the spoon will start rising. So this is how the heat is transferred in solids, and this particular procedure or the process by through which the heat is being transferred in solids is called conduction. So you got my point?
Yeah.
So let us see that what your note says about it. It says that conduction is a process where vibrating particles transfer energy to their neighboring particles. That one vibrating particle transfer energy to its neighboring atom, and it will then again transfer to another particle, and it will again transfer its energy to another particle, and this is how the thermal energy will reach to the you can say the other end of the spoon, which is in air and which is not directly connected with the heat source, because heat source is the bowl in which there is a hot soup. So that is the heat source. The other end of the spoon is not connected directly to that hot source, heat source, but still the energy, the thermal energy is transferred to that part. And how this is transferred to that part, this is basically transferred through conduction. So I guess it is clear to you.
Yeah. Okay. So that was all conduction, am I right?
Yeah, this process is called conduction, in which the thermal energy is transferred through vibrating particles in solid. Okay.
Okay. Yeah.
Oh, okay.
Yeah.
So energy is transferred, energy transferred to an object by heating, and is transferred to the thermal store of the object, that this is converted. This energy is shared across the kinetic energy stores of the particle of the in the object. That I have told you that the thermal energy is given to this particle, and it is converted to the kinetic energy store of this particle, and it starts vibrating more. So the particles in that part of the object being heated vibrate more and collide more with each other or with other atoms. So these collisions cause energy to be transferred between the particles, kinetic energy. So when it collides with another atom, it will, you can see that, let us say there is a particle over here and there is a particle over here, and when they collide, this particle, if even if it is stationary, if they collide, it will move a bit. So it means it this lower particle transferred energy, kinetic energy, to this upper particle. So this is how energy is transferred from one particle to another. So this is basically called conduction. This process continues throughout the object until the energy is transferred to the other side of the object. As I gave you the example of spoon, that this process keeps on going and until the other side or the other end of the spoon gets heated. So it is then usually transferred to the thermal energy store of the surroundings. Now what happens next? When the other end, even the other end of the spoon is heated, now what happens? The energy will transfer to the surroundings. This thermal energy will be then transferred to the surroundings, and some after some time, the spoon as well as the soup will get colder. So this is how the energy is transferred through conduction. It is then usually transferred to the, okay, we have studied it. Thermal conductivity is a measure. Now we have an important term which is conductivity. Do you know about conductivity? What does conductivity means in general?
Like, how much something. So like, isn't that how much energy it takes in?
Basically, you can think of conductivity as a property of a substance, that how much heat it allows to pass through it, or how much, even conductivity is also in electricity. So that conductivity is called electric conductivity. So even how much current it lets to pass through it is called the conductivity of that substance. So here we are more focused on the thermal conductivity of the substance. What does thermal conductivity is of a substance means? Basically, it is a property of that substance, that how easily it conducts the thermal energy, or it conducts the heat, or how much heat it allows to pass through it. So there are certain substances we don't let the heat to flow through it, like wood. You have
Okay.
seen that it is, even if a wood is burning, even there is fire on the one end of the wood, the other end of the wood will not get heated. And on the other hand, if we talk about the spoon, if it is made up of conducting material, so if it is, even it is placed in a hard soup, the other end of it will get heated. So how these two things are different? Basically, the thermal conductivities of these two substances are different. The substance which allows more heat to pass through it will have higher values of thermal conductivity, and on the other hand, the substances which don't let the heat to pass through them easily, so the conductivity of those substances, you can say, is less. So in these examples which I am talking about, in case of wood, the thermal conductivity is very low. It don't let the heat to pass through it. And on the other hand, the thermal conductivity of the spoon is high, and it let the heat to pass through it from the one end of it to the other end very easily. So this is the concept of thermal conductivity. What is thermal conductivity? It is a measure of how quickly energy can be transferred through a material. In this way, materials with a high thermal conductivity transfer energy between their particles quickly. So this is what I want you to learn, that those materials with high thermal conductivity, the heat can pass from them very easily and very quickly. So I hope it is clear to you that what it means by the thermal conductivity.
Yeah, it's clear now. Because
Uh,
before it's a bit. I still got it though, like it was still.
if you have any doubt, you can ask. You are
I
welcome to
know
ask any
it's
question.
fine.
Okay.
So
Yeah, you want.
so can I? repeat that a bit. So like conductivity is a measure of how quickly energy passes through an object.
Yes. So what does high thermal conductivity mean? That let us say I say that a particular substance, let us say that iron have high thermal conductivity. Then what does this mean?
So that it passes through very easily.
Yes, and very quickly. The other end of this of that iron rod will
Yeah.
get heated very easily and very quickly. Okay.
Yeah.
Okay. Now convection. Convection is basically another type or another process through which heat is transferred from one part of a from one part of a body, you can say, or from one part of system to the other part of the system. And I have told you earlier that convection occurs only in case of liquids and gases, right?
Yeah.
Liquid and gases. I have told you that in case of liquids and gases, the particles or the atoms are not closely attached with each other. They randomly move in, like if you have let me say, let me give you an example of let us say we have a gas cylinder. Then in that box or in that cylinder, the gas particles will continuously roam around, and they will they will be continuously moving from one point to another. A particle which is, let us say, at the bottom of that cylinder will be at the top of the cylinder in the next moment, and can have any type of movement and can change its position, right? So how convection occurs basically in this type of you can say heat transfer, the particles which gets heated moves to the other part of the it moves towards the other part of that body or that gas or that you can say liquid. So how this happens basically in are you familiar with the concept of densities?
Yeah, density is like how much is it? Yeah, that's like how much particles it has in like a substance. Like for example, metals are really dense.
Yes, exactly. Basically, we have a formula for density. Let me write it for you so that you can be a bit more clear with it. We represent density by rho, and it is equal to, usually it is equal to the mass per unit volume. That how much mass of a substance is contained in a certain amount of volume. When we as you have talked about the metals, when we talk about the metals, in a very small amount of, you can say, small, in a very small volume, there will be, they are still very massive, the metals are still very massive, so that's why they have higher densities. While on the other hand, if we have the gas in that amount of, you can say, let us say we have two cylinders. Let us say I want you to learn it more. Okay, let us say we have two equal cylinders. The one is filled with the gas. Let us say this is one is filled with gas, and this one is filled with the metal. Like it is, you can say this gas, this cylinder is fully there is no space in this cylinder, and it is fully made up of an iron. You can imagine it as an iron rod. So those volume of both of these cylinders is same, still which will be a bit more heavier, which will be more massive. Of course, this metallic one, it will be more massive. So it, why it is more massive? Because it has much more density as compared to gas. So this is what the density means. Okay.
Okay.
Okay. I have, why I have told you this concept of density is because this concept of density is important in convection. How we will see it in a moment. Basically, in convection, the energetic particles move from hotter to colder regions. Basically, I have told you that in liquids and gases, atoms and particles are free to move. So when we heat certain part of a gas or a liquid, the particles in that part will move from the hotter region to the colder region. So convection can happen only in gases and liquids. You must keep it in mind. Why? Because in solids, you know that the atoms cannot move from one part to another, and the energy is transferred by heating to thermal energy of the liquids and gas. And again, this energy is shared across the kinetic energy stores of the gas or the liquids particle. That again, what happens when we give the heat to certain, let us say, we have let me write something. Okay, let us say we have this cylinder and there are gas particles in this cylinder, and we have kept it on fire here. Okay, so there are gas particles in this cylinder. They are roaming around. So what will happen? We are providing heat to this lower part. Can you hear me? Hello?
I can't hear you that well.
Talha, I'm sorry. I guess there is a connectivity issue over here. Can you hear me now?
Yeah, it's better now.
Okay. So what happens is, let us say that we have a cylinder of gas filled with the gas, and we have kept it on fire. And what happens now? The particles in this region, in the lower region of this cylinder, will get the thermal energy from this heat. So, Tala, can you hear me?
Yeah, I can hear you now.
Oh, okay. So the thermal energy is transferred to these lower particles, and they will what will happen? This thermal energy will be transferred to the kinetic energy of these particles, and they will start moving upward towards the colder region of that cylinder, and these colder particles will start moving downward. Okay, so what happens that the thermal energy is transferred to the kinetic energy stores of these liquid or gas particles. And unlike in solids, the particles in liquid and gases are able to move, as I have told you. So when you heat a region of a gas or liquid, the particles move faster, and the space between the individual particles increases. This increases this cause the density of the region being decreased. Now what happens? More of the particles will above move towards the colder region. So here the particles will be less, and still the volume is same. So if we have less particles or we have less mass somewhere, so it means the density over at that portion of the cylinder will decrease. Are you getting my point?
So after it loses energy, it rises like down. The energy like decreases after time.
That is another case. We will see it a bit later. Till now, you need to what you need to learn is that when we heated these particles, these hot particles start moving upward in the colder
Yeah.
region. In the colder region, so there are less number of particles in this region, in this lower region, right? There are
Yeah.
less number of particles in this colder region. So what happens, as you can see in this formula of density, when we have less number of particles or we have less mass, so density and the volume is fixed in this portion, so the density will start decreasing gradually. Are you getting my point?
Yeah, okay.
So what happens that if the density is low at some point and high at the other point, then what happens? Because the liquid and gases can flow, the warmer and less dense region will rise above the denser or cooler region. So what happens that you can see How can I explain it to you? Okay, so you can see, you can say that whenever we have less dense, let me give you an example of ice. You have seen that ice floats over water, right? Why,
Yeah,
why the ice,
water.
why the ice cubes don't sink in the water? Why this happens? Basically, the density of that ice cube is less as compared to the water. That's why it floats over the surface of the water and it never sinks in. So this is the same concept, that the less denser regions will start moving above and the more denser region will start moving downward, and this is how the energy, the thermal energy is transferred from one part of a gas to another part of a gas. So is it clear to you that how in convection the heat is transferred from one part of a gas to another part of gas, or one part of liquid to another part of liquid? Is it clear to you?
Yeah, it's clear.
So moving forward, we have some examples of we have an example of a radiator in a room, that how when we turn on a heater, how this the whole room gets hot. So first of all, you can see from the first point, heating a room with a radiator relies on creating convection current in the air room. That basically this you can say this process of heating the room through a radiator is based upon the convection of the convection process, is based upon the convection process.
Okay.
So
That's why I need to switch the radiator off. It slowly cools down the air.
uh, it heats the air. Basically it heats the air. You will see how basically let us say we have this radiator, we have this radiator, and the you can, you know that there is air all around us, and there must be air particles around this radiator as well. So these air particles basically strikes, or you can say these air particles collide with this radiator and get the thermal energy from the radiator, and they will then move. Basically at this first stage the heat is transferred through conduction, because these air particles are, you can say, collided with the radiator. But then what happens, these particles will get the thermal energy from this radiator, and then this thermal energy will be transferred or will be converted to the kinetic energy of the particles, and these particles will start moving. And when they move, there will be less dense region over here, and these cold particles will start moving towards this less dense region near the you can say the near the radiator. So these particles are moving away, the hot particles are moving away, and the cold particles are moving towards the radiator. Now what happens next, these cold particles again get collided with this with this radiator and get the thermal energy from the radiator, and again they move away from this radiator, and those particles which moved away from the radiator strikes with the walls of the room and with all the objects which are placed inside the room, let us say the sofas and every object, and they transfer their thermal energy to those particles and again cool down, and again they move towards the radiator. So this cycle,
Why
sorry,
why does it move towards the radiator?
because they again
The
cool down,
cooler.
they transferred the energy towards to the objects or to the walls, and they get cooled down, and they are more, now they are more dense. So and the there is the density near the radiator is less, so they move towards those less dense areas, and then they again get heat up, and this cycle continues until our whole room gets heated up. So this is how the heat is transferred from the radiator to the whole room. You got it?
Okay.
You got it, or you have some confusions?
No, I get it now. It's fine.
Oh, okay. So moving forward, you can we can read it out that what it says in the first step. heating a room with a radiator relies on the convection. We have read it. Energy is transferred from the radiator to the nearby air particles by conduction because they collide with the radiator. As I have told you, the particles which are near the air particles which are near the radiator will collide with radiator and get the thermal energy through conduction, and then the air by radiator becomes warmer and less dense. So the air which is near the radiator becomes warmer and becomes less dense, so it will move away from these particles, move quickly away from the radiator. The warm air rises and is replaced by the cooler air, and the cooler air will move towards the radiator. So the cooler air will again strike with the with this radiator and gets heat, and then it will again move, and this is how the cycle continues and the whole room get high, right?
Yeah.
So this cycle repeats and we get the hot room. So this is how things happens through convection. We have studied that heat is transferred by two means. The one is convection and the other one is conduction. In conduction, conduction occurs only in solids, while convection occurs in liquids and gases, and it doesn't occur in liquids in solids. Because why? Because in conduction, the heat is transferred through the vibrations of the particles, while in convection, the heat is transferred through, you can say that through the movement of those particles which get heated. So this is how this happens. The energy transfer happens. So now moving forward, reducing the unwanted energy transfers. We have studied in yesterday's class that we have certain energy losses. So can you tell me what is meant by energy loss or energy dissipation? We have studied it yesterday.
The law for energy.
Sorry, I couldn't.
Sorry, what did you say?
I said that can you explain what we have studied about the energy dissipation or energy losses yesterday? What was that? What is meant by energy loss, or what is meant by energy dissipation? We have studied it yesterday.
Energy dissipation is when energy is lost.
Yes.
Through light surrounding and is transferred.
How energy is lost? What it means by energy loss?
Is transferred to another energy store.
Energy transfer from one energy store to another energy store is not the energy loss, it is energy transfer. What is meant by the energy loss? Basically, if the energy is transferred to those energy stores which are not useful for us, or which are less useful for us, then we can say that this energy is lost or this energy is dissipated. I gave you the example of a bulb, that when we give the electrical energy to the bulb, we turn it on, we get the light energy, and then after some time the bulb gets heated. So some of its electrical energy is transferred to the heat energy as well, and so the other part of the energy is transferred to the light energy. The light energy is useful for us, but that heat which we get from the bulb is not useful for us. So this is the energy loss or energy dissipation, right?
Yeah.
So now we are going to study that how we can reduce those losses, or you can say that how we can take full use of our energy. We can never take the full use of energy. You need to keep one thing in mind, that always there must be some losses in the energy. It can never happen physically, practically it can never happen that the energy is completely transferred to a useful energy store. So there are losses. They cannot be removed, but they can be reduced. So we will see that how we can reduce these energy losses. Basically, there are two things which are useful for reducing the energy losses. Basically, the first thing which is used for reducing the energy losses is lubrication, and the other thing is thermal insulation. We will see both of these things. Let us say that let me give you an example. When you drive a car, what happens that the road will have some friction. It will definitely have some friction. Are you familiar with the frictional force?
Friction's like when there's rubbing between two like surfaces that like slow something down.
Yes, basically it opposes the if two bodies are in contact and one body is moving over another body, the other body will oppose the motion of that body, and that opposing force is called frictional force, right? So if you are driving a car, the frictional force will try to stop that car. Or let me give you another example. Let us say we have a box placed on the floor and you want to drag it from left to right. You push the it from left to right. You provide the force to this box, and if it is a very massive box, it will be very difficult to move it from this point to a point over here. Let us say it will be difficult. Now why it is difficult? Because the floor will provide the frictional force to this box. So now the concept of friction is clear to you.
Yeah.
Now what is happening? Basically, due to this friction, some of our energy is lost. So we want to reduce that energy loss. So how we can reduce that energy loss? Basically, we just use the lubricants in order to reduce this energy loss. Now what is lubricant? Lubricant is basically a liquid, or you can say there are certain type of oils which reduces this friction, and it lets this box moves very easily. If there is let us say that if we sprinkle some sort of oil over it, so now this box will be a lot more easier to move. So we need to give it a little less energy to this box in order to move. So how this is happening? Because this lubrication or this oil reduces the energy losses. So this is why we can easily move this box. So are you getting my point from this example, that how we can reduce the energy losses through friction?
Yeah.
uh,
So
basic
it just it like
Yes.
just smooths out and reduces the friction.
Yes, it, and you know that the friction is basically frictional force is basically the cause of energy losses. So when we reduces this frictional force, it means we are reducing the energy losses. So this is how we can reduce the energy losses through lubrication, right?
Yeah.
Okay, so let us say what your notes says about it. In the first point, it is written over here that whenever something moves, there is usually at least one frictional force acting against it. That whenever the body moves, it will definitely have some frictional forces over it. This cause some of energy in the system to be dissipated, or some of the energy to be lost. So these frictional forces are the cause of energy losses, right? So what happens is that now what happens that we want to reduce this frictional force in order to reduce the energy losses. So we can reduce this frictional force by lubrication. uh, for example, it is written that air resistance can transfer energy from a falling object's kinetic energy store to its thermal energy store. Let me give you another example in it. Let us say you have a swing. Do you know what is a swing? like it's in parks, the swing,
Oh yeah,
right?
yeah,
So if you just the swing is hung over here, and if you just take it to this point, it will start oscillating, like it will move to forward, and then it will again move back, and then again and again, and after some time it will stop if you don't keep on pushing it from this point, right?
yeah.
So why it stops? There might be some reason, no? There might be something which which stops this swing from swinging,
Is
right?
it friction?
It is basically air resistance, which reduces or the kinet when it is moving. It have the swing When the swing is moving, it means it have some kinetic energy. Now this kinetic energy is being lost to do work against the air resistance. Air resistance is a friction. It stops the swing to move, so that kinetic energy is transferred to the useless, you can say, useless work which the swing have done against the air resistance or air friction. So this is the concept that we just that the energy is transferred from the kinetic energy of that body to the air resistance or to the energy losses, right, due to friction. So what the lubricants do, lubricant reduces this frictional force, and in the other words, it reduces the you can say the energy losses, right?
Yeah.
Are you following me till here? If you have any question, you can ask Tala, because this is a discussion session and I want you to participate in it.
Well, I don't really have any. Actually, you know when you're talking about swings,
Mhm.
can't like gravity be one factor?
Yes, gravity can be a factor, but we can say that it's very negligible. Why? Because how gravity acts, it basically attracts the thing to move downward, so it can affect the body's vertical motion, and it don't really affect the horizontal motion of a body. So gravity only, you can say that it can only affect the motion of a body when it is moving vertically upside down. If it's moving from left to right or from backward to forward, so the gravity will not contribute much in this case, right?
Okay.
So
Yeah.
you got my point? Talha, you got my point?
Yeah, I get your point now.
Okay, okay. So there is another way of reducing the energy losses, and how it can be done. Basically, when we talk about the heat energy, like, let me give you an example, because with examples you can understand more. Okay, you have a cup of tea. We have talked a lot about it. It contains the hot tea, and after some time the tea gets colder. Why? Because the thermal energy of the tea is transferred to the thermal energy store of the surroundings, right?
Yeah.
Let us say we don't want this tea to get colder soon. So it means that we don't want the thermal energy of the tea to be lost. So what we will do the thermal flask, in order we will contain this tea in the thermal flask, so it will remain hot for a long time, right? Are you getting my point?
Yeah.
So how that thermal flask works? Basically, that thermal flask will be made up of a thermally insulating material. It will be made up of a material which don't let the heat to pass through it. So that thermally insulating material, what will it do? It will not let the heat to move from the surroundings to the system, and it will also not let the heat to to be transferred from the system to the surrounding. So this is how the energy, the tea will be kept hot for a longer time. So but still, after some time, if let us say if in a cup the tea gets colder in, let us say, 15 minutes, but in that thermal flask it might get an hour or two to get the tea colder, but still the tea will get colder. It will not remain hot for all the time, right? This happens now, that
Yeah.
it will cool down after a certain amount of time, though it takes longer to get cool in that thermal flask. How? Because still, as I have told you, that never ever it is possible that you remove all the energy losses. There will be still some energy losses in that insulating flask, but these energy losses will be a little less. So what happened is that you have reduced the energy losses using the using insulation or insulating material. So do you get my point?
Yeah.
That how insulation reduces you can say the energy losses.
Energy loss. Yeah.
So
With
yes,
yeah.
yes, Tala, please carry on.
I know it's fine. It's fine.
Okay, so this is how we just studied that there are always energy losses, but we can reduce those energy losses. We cannot completely eliminate those energy losses, but we can reduce those losses. And how we can reduce those losses? We have studied the two ways of reducing those energy losses, and the first one was the energy, you can say, the first one was through lubrication and the other was through insulation. So this is how things happens, right? So moving towards the efficiency, what does efficiency means? Can you please tell me what does efficiency means in general? I'm not talking particularly about the physics, in general.
Isn't efficiency like how useful something is?
Exactly. Or yes, exactly. You are right. That how useful something is. Now, what does the efficiency means in case of in case of physics? Uh, right. Let me tell you through an example. Whenever we do work, we give some energy, right, and this energy is
Yeah.
transferred to some other form of energy, and which is and we want that energy transfer to be useful for us, right? So what happens, I have told you that there are energy losses in every case. So in case of efficiency, what happens is, how can you measure the efficiency of a system or of a body? Basically, if you are giving the input energy to a body and it is converting most of that input energy to the useful to the useful energy transfer, or to a useful energy store of to another useful energy store. So it means most, if it is using it is converting most of the input energy to a useful output, so it means it will have more efficiency. But if it is like there are more of energy losses, so it means the efficiency of that body is less, right?
Can you please repeat that?
Basically, what does efficiency means? I'm saying that whenever we want to do something, we want to do some work, we need to input some energy, right?
Yeah.
So if that input energy is converted to most of that input energy is converted to a useful energy store, then it means that body is more efficient. And if more of the input energy is lost or is transferred to the useless energy stores, and only some of the energy is transferred to a useful energy store, then it means that the efficiency of that body is not is very less, right? Let me explain it to you with an example. Let us say we have two students, right? Both of these students studies for 2 hours, right? So both of it means that both of these students gave an input of 2 hours, right? They appear in an exam, and one of that student gets 80% marks, and the other the other student just gets 40% marks. Let for sake of example, so one student get the 80% marks, the other student gets 40% marks. Both of the students gave the same input. They both of them worked for 2 hours. The input was same, but the output is different. So it means the one with the greater amount of output is more efficient, and the one who just couldn't perform well, and the output of the that student was less, so it means that that student is a bit less efficient as compared to the other one. So this is what efficiency means in physics, that when we input some energy and most of it is transferred to a useful energy transfer store, so it means that body or that object or that system is more efficient as compared to the one in which there are more of the energy losses and some amount of energy is transferred to the useful energy store, and so it will be less efficient. So I hope the efficiency is clear to you now. Talha, are you there? Hello? Hello? Hello?
Sorry, I think my internet was a bit.
Yes,
Uh,
you were disconnected for a while. Have you heard why what I have told you? I gave you an example of the students. Have you heard that?
for efficiency,
Yes, yes.
yeah. Wait, so like you're saying like how much energy they put into like how do I say that?
I'm saying that if the most of the energy is used in a useful work, or you can say in a useful energy store, then it is more efficient. And if a body is
Okay.
like I gave you an example of the two students, and that in let us say we have two students A and B, both worked for 2 hours for an exam, both worked for the 2 hours. Now after the exam, the student A gets 80% marks, and the student B let us say gets 40% marks. Now the input was same, both of them worked for 2 hours, both of them input 2 hours, gave the input of 2 hours, but the output of the student A is more as compared to the output of student B. The student A gets more marks, and the student B gets less marks. So we can say that the student A is more efficient as compared to student B. So is it clear to you now?
Yeah.
So this is what the efficiency means in physics, that if most of our input energy is utilized in a useful work or in a useful energy store, it is converted into a useful energy store, then then that body will have more efficiency. And if there are more energy losses and some of the input energy is transferred to a useful work, then that body will be less efficient, right?
Yeah.
So as I have told you that we can never eliminate the energy losses. So what does this means? That no system can be 100% efficient. It can never happen that that a system converts all the input into the useful work done. So it can never happen. So it means a body can be never ever 100% efficient, right? Talha, do you get
Yeah.
did you get my point that a body can never be
Yeah.
100% efficient?
Yeah. So Because
Uh,
there was another example in the book as well.
Sorry, I couldn't hear you.
Oh no, I was saying that I was looking at the example in the book.
Okay, okay. Uh,
Um, yeah.
uh, okay. I hope efficiency is clear till here.
Yeah.
Okay, Tala. Let us take a break for 10 minutes, if you say, and
Yeah, no, that's fine.
then we will come
Yeah.
back at like it's 2:57. Then we come back at 3:07. Okay.
Should I stay in the call or should I leave?
It's up to you.
I'll stay in the call and put my mic on mute if that's fine.
Okay, okay, that's fine. So see you after 10 minutes.
Okay.
Hello. Hello.